In previous video, you have studied about the introduction of atomic structure and the different fundamental particles of atom. You have studied about Dalton's atomic theory and then the fundamental particles of an atom, that is the discovery of electron, that is the discovery of cathode rays and its properties. Now in this class we will study about the discovery of proton and the discovery of nucleus. Now it was seen after discovery of electron that electron, which is a negatively charged particle, which is the constituents of every atom. It comes from every matter. But as we know that atom is electrically neutral. So there must be some another particles which will carry positive charge to neutralize the negative charge of the electron. Keeping this view in mind, scientists further tried to perform more experiments and discover the positive particle. Now, so it was the discovery of anode rays, which is also known as canal rays. We will discuss why is the name given. Now, anode rays, or we can say it was the discovery of proton. Now, we have studied or seen earlier, that is, it was E. Goldstein who discovered proton. Now, in order to perform the experiment, he again used the similar discharge tube which was used in cathode ray discovery. But there was one structural change, that is, he placed perforated cathode plate in the middle part of the tube. Perforated means having holes. That is, this was the structure of the discharge tube used by Goldstein, which has perforated cathode plate, and then on the another side this is negative, that is cathode, and here it is positive anode, and again there was the tube connected to the vacuum pump. Now again the voltage of 10,000 was applied, having gas at pressure of 0.01 mm of Hg. So this is the discharge tube used for discovery of anode rays or proton. Now again remember, this is the structure. When current was passed at very high voltage of 10,000 volt through the discharge tube, having gas at 0.1 mm of Hg and perforated cathode plate placed in the middle, then it was observed that some rays were also reaching behind the anode, behind the cathode plate. Although like this one, some rays were traveling from cathode towards the anode, that was the cathode ray, but some rays were reaching also behind the cathode plate, that is coming from anode towards the cathode, where it was glowing or it was producing fluorescence on zinc sulfide glass screen. Since these rays were coming from anode towards the cathode, hence termed as anode rays, and since the rays were passing through the holes present in the plate, hence termed as canal rays. Again remember, some rays were seen to be reaching behind the perforated cathode plate. It means that it was traveling from anode towards the cathode in the direction opposite to cathode ray. Hence, it was termed as anode rays. Since the rays were passing through the holes in the perforated cathode plate, therefore, it was termed as canal ray. So, this is perforated. Perforated means having holes. Perforated cathode plate. Cathode plate. So this was the discovery of anode rays, which is performed by E. Goldstein. Now, here we have to study properties of anode. Properties of anode rays. Now, the properties were studied by using the similar aspects, similar concept that was used for the cathode rays. Like, when in the middle or in the path of the anode ray, some opaque object was placed, it casts shadow behind the plate. Hence, they travel in a straight line. They travel in a straight line. A straight line. The reason is that they cast shadow. Next, deflected in electric or magnetic field. Magnetic field means it was particle. Now, as well as that is deflected towards negative electric field. Hence, consist of positively charged particles, which was termed as positively charged particle named as proton. Now, second point. Third, these protons were producing, or anode rays produce fluorescence in zinc sulfide. Now, the same topic was studied in the discovery of properties while studying the properties of cathode rays. So, it was also having the similar property. Next, as anode rays, when again light pedal wheel was kept placed in its path, it produced motion in it, rotation in it. Means it had kinetic energy. That is, they have mass. So, that is, they consist of minute particles having kinetic energy. Now, so students, we have mentioned some of the important characteristics of anode rays. Again, summarize it. Anode rays. First, they travel in a straight line. Second, they are deflected in electric or magnetic field, and in electric field, it was deflected or attracted towards the negative plate, and hence it consists of positively charged particles called proton. Next, they produce fluorescence in zinc sulfide screen. That is, it was capable of producing fluorescence, energetic particles. And finally, they consist of minute particles which have kinetic energies. So, now these were the different properties of anode rays. After that, if we have studied it, then further the anode particle were studied separately and their properties compared. So, properties of proton. If you will study electron, proton and neutron in comparison, then you will be able to learn it more easily. Like the first point which we have used for electron was symbol. For proton, it is +1 and 1. This +1 indicates that it has 1 unit of positive charge. This superscript 1 indicates that it has mass of 1 AMU. Now we will write later on. Now suppose its charge. Again, you have studied, written it in electron, the charge and mass in two types, that is the relative charge and the absolute charge. Similarly, you will also write here charge. Relative charge. Relative charge is +1 unit, also termed as, in short, we have written earlier ESU. That is also termed as electrostatic unit, the collection of charge which is taken as unit. Now, absolute charge. Absolute charge is +1.6 into 10 to the power -19 coulomb. For electron, we had used negative 1.6 into 10 to the power -19 coulomb. Now, we will study furthermore. Now, then there is mass. Again, relative mass. Relative mass, that is 1 AMU, or we can write 1837 times the mass of electron. Mass of electron. That is, it is similar to the mass of one hydrogen atom. And finally, absolute mass. It is 1.672 into 10 to the -27 kg. Now, just see here, students, that is the mass of an electron was 10 to the power -31 kg, and here it is 10 to the power -27 kg. It means that the mass of a proton is about 10,000 times more than the mass of an electron. So, we have studied now about the discovery of anode rays. After this discovery, we come to know that an atom is electrically neutral. It has the similar number of positive and negative charges, that is the electrons and protons. Considering the discovery of the existence of these two types of particles, scientists tried to explain the composition of an atom, the arrangement of these particles in atom, showing the atomic structure. And the first arrangement was discovered by J.J. Thomson. J.J. Thomson gave Plum pudding model. Plum pudding model of atom. It is also compared as watermelon model. Watermelon model. वाटरमेलन को हम लोग कॉमनली हिंदी में तरबूज बोलते हैं. सो सिमिलर टू दैट. According to this model, plum pudding model, he told that the complete atom is in the form of a sphere of uniformly distributed positive charge, in which the electrons, that is the negatively charged particle, is distributed or suspended in that sphere of positive charge. Like, come to this part again. Suppose in a watermelon, now there is a reddish fleshy part inside it. That reddish fleshy part will be similar to the distribution of positive charge throughout, and the seeds in it which are scattered are like negatively charged particles. So in this case, watermelon model, we see that the uniform, this has uniform positive charge in a sphere, and the negatively charged particles, that is the electrons, were embedded in it at regular interval or at different points, different places. This is called plum pudding model, or also known as watermelon model. This was the arrangement of these two particles given earlier. But this was not satisfactory explanation. Later on, more scientists tried to explain or find it out. It was Rutherford, Rutherford or Ernest Rutherford, who performed his experiment in 1911 AD, that is when he discovered the existence of nucleus, the arrangement of electrons and protons in the atom. And this experiment performed by Rutherford was known as, popularly known as, alpha scattering experiment. Alpha scattering experiment. Now, what is alpha particle? So, first of all, suppose we write here alpha, symbol is this one, alpha particle. Just explain it, and then we will use this term, this particle in Rutherford's experiment. Alpha particle. It is the positively charged particle. It is positively charged particle having +2 unit of charge and 4 AMU of mass, similar to helium nucleus or He2 plus ion. Like, it is compared with that because helium has atomic number of 4. Atomic number of 2 and mass number of 4. That is, it has 2 protons, 2 electrons in its orbit, 2 protons and 4 unit of mass. So suppose the helium 2-4. If you draw its structure, here it is, although it will be studied later on in detail, 2 neutron and 2 electrons are present here. Now suppose it loses its 2 electron, it changes to He2 plus ion. He2 plus ion. In this case, if we take atomic model, then this part will have just 2 proton and 2 neutron, no electron at all. Hence, it is termed as helium nucleus. And because in it there is only one orbit, but orbit is vanished, only nucleus is left, and this will carry 2 unit of positive charge due to the presence of 2 proton only in the nucleus. This is the alpha particle. And how is it obtained? So it is obtained from radioactive substances. So if it is asked that what is the source of What is the source of alpha particle? Then we say radioactive substances. So students, just I have, before going to start with the alpha scattering experiment given by Rutherford, just we have explained about the alpha particle. What is it? Now let us start with the Rutherford's nuclear model or Rutherford's alpha scattering experiment. Rutherford's experiment also known as alpha scattering experiment, and this was the experiment to discover nucleus, discovery of nucleus. So now you students, you see, if the question is asked that who discovered nucleus, then it is Rutherford. Now how was the experiment performed? For this experiment, he bombarded the beam of alpha particles over very thin gold foil, very thin gold foil, that is 1/1,000,000th of 1 centimeter about. The question arises, why was the gold selected by him? The reason is that the gold is the most malleable metal, that is very thin gold foil sheet of gold can be obtained by hammering. That is the malleability. So among the metals, gold has the maximum malleability. Very thin foil of it can be made. So he selected gold element. Now, so for his experiment, he bombarded beam of alpha particles over very thin gold foil, over very thin gold foil. Like suppose we take this part of the atom of the in the sheet of it. Now this was the experimental part. Alpha particles from the source of radioactive substances were thrown, or that is were directed towards the very thin gold foil. Now it was observed, and suppose on this side fluorescent screen was placed, suppose, then it was observed that most of the alpha particles passed undeviated. It means that there was no obstruction in its path, showing that the large part of an atom is empty. Second, very few got deflected towards some small angles. Very few got deflected by some small angles, and very few, 1 out of about 10,000 got deflected back. 1 out of 10,000 got reflected back. It means that, now you see, it is here. Why is it deflected? Because it is positively charged. So if there will be the positive charge in front of it or in its path, the like charges repel each other. So positive particle was repelled by some positive part in its path. 1 out of 10,000 is reflected back. It means that in a very small space, there was total positive charge concentrated which was just in front of it, so it was repelled back, it was reflected back. So this was the alpha scattering experiment. Now, after understanding it, you will write it as the observation of alpha scattering experiment. First point, large number of alpha particles passed undeviated. This is the first observation. Second, very few get deflected by some small angles. And finally, now you see, that is the third one, very few about 1 out of 10,000 alpha particles reflected back. So these were the three major observations made by him on the basis of his experiment. Now, studying it, he concluded, that is, what was its conclusion? That large number or large space in the an atom is empty. Total positive charge and mass of the atom is concentrated in a very small space at the center of the atom called nucleus, and electrons revolve around the nucleus in circular paths called orbits. So these were the major conclusions. Now we can write, according to the experiment, we can write the Rutherford's atomic model. Rutherford's atomic model. Rutherford's atomic model. First point, large space of an atom is empty, and this point was taken because most of the alpha particle passed undeviated. Next, total positive charge and mass of an atom is situated in a very small space at the center called nucleus. So first word nucleus was used by Rutherford, hence we say that nucleus was discovered by Rutherford. Now next, third, that is, the electrons revolve around nucleus in circular paths called orbits. Now next point, he told that atom is electrically neutral. So these were some of the main points of Rutherford's atomic model. The basic one is here, 3 points. The large space of an atom is empty. Total positive charge and mass of an atom is situated in a very small space at the center called nucleus, and electrons revolve around the nucleus in circular path called orbits. One more point can be retained, that is the size of nucleus is very small in comparison with the size of an atom. Like you see, suppose we write the size of an atom is in the order of 10 to the power minus 11 meter, and size of nucleus is in the order of 10 to the power minus 15 meter. So this is a comparative study. So students, this was about Rutherford's atomic model. Now I think it is clear to you. Students, after discovery of nucleus by Rutherford, again further more points, more aspects were studied, and it was found that there is some demerit of Rutherford's model. And what was it? He was unable to explain the stability of an atom. How is the atom stable? Like that is, this is the drawback of Rutherford's model. What was drawback? Then he failed to explain stability of an atom. Now what was the reason? According to modern theory of mechanics and electrodynamics, it is seen that when a charged particle is in motion, then it continuously radiates out energy, means it loses energy. So in case of atom also, the electron, which is a charged particle, is revolving around the nucleus in orbits, so it must continuously lose some energy. As a result, it will be gradually pulled towards the nucleus, and by taking a spiral path, it will fall into the nucleus, and hence the atom will collapse. But as we know, it does not happen. The atom remains stable. So the main drawback was that he was unable to explain stability of an atom. Like we have seen, suppose in the center there is positive nucleus, and if an electron is revolving in the orbit, then by taking a spiral path, it will fall into the nucleus, and hence the atom will collapse. But atom is stable. Then this drawback was solved by another scientist. It was Niels Bohr, who explained the stability of an atom by putting some concepts or thoughts of him. Like you see, next is Bohr's model. Bohr's atomic model, or we can write Bohr's model. It was Niels Bohr explained stability of atom. How was it explained? Then all the previous points were similar to Rutherford's experiment. There was no change. That major part of an atom is empty. Total positive charge and mass is situated in the center called nucleus. Electrons revolve around the nucleus in definite circular path called orbits. And each orbit is associated with definite amount of energy. Hence, they were called cells or energy levels. As long as an electron, this is the major point, This is in order to explain the stability. As long as an electron revolves in an orbit, its energy remains constant. But when an electron has to jump out, that is, has to be removed, has to come from inner to outer orbit, then it absorbs extra energy. And when an electron has to jump to inner orbit, that is from outer to inner, then it will have to radiate out, it will have to release extra energy in order to become stable. So now you see, that is the Bohr's model. First point, total positive charge and mass of atom is situated at the center in nucleus. Second, electrons revolve around nucleus in definite circular path called orbits, which are associated with definite amount of energy, hence they are called cells or energy levels. This is the main point. Third, as long as an electron remain in an orbit, its energy remains constant. Fourth, when an electron has to jump out, that is from inner to outer orbit, it absorbs energy, means it requires more kinetic energy. And when it has to jump from outer to inner orbit, it releases energy. So these points were able to explain the stability of atom. Means an electron can remain in its orbit with constant amount of energy endlessly. Its energy will not change unless it has to jump from one orbit to another orbit. And lastly, orbits are marked as K, L, M, N and so on, or 1, 2, 3 and so on, starting from the closer to the nucleus. Now, so this was the Bohr's model of atom. Like, if in the nucleus, this is the nucleus, now this is the first cell, second, third, fourth. Now this is K cell, L, M, N, also marked as 1, 2, 3, 4 and so on. So this is the arrangement of electrons and protons in the nucleus of an atom. Next, last part. Now, students, later on scientists found that the total mass of an atom is greater than the number of protons situated in it. Like helium nucleus has 2 protons. Therefore, the mass of helium should be 2. But it is found that the mass of helium atom is 4 amu. It was clear now that there must be some another particle in the atom which will have no charge, means neutral, but will have mass equal to that of the proton. Since it was electrically neutral, hence the name given as neutron. Now, it was discovered by James Chadwick. Now, further we see that neutron, how was it discovered? Then he bombarded light nuclei like beryllium. He bombarded light nuclei like beryllium by alpha particles and got neutron. For example, we see beryllium 4, atomic number, mass number 9, was bombarded by helium 2,4, that is alpha particle. Then it was observed that another atom was formed, this one, and this particle was also formed, that is called neutron. So this was the discovery of neutron. Now you see that if you study its property, similar to the another initial topics, its symbol, it is written as 0 and 1. This is the symbol, this is the charge, this is the mass. So again, charge 0 and mass similar to that of proton, that is 1 mu or 1.676 into 10 to the power minus 27 kg. So thus students, we have seen that there are 3 basic particles, fundamental particles in an atom, that is electron, proton and neutrons. Electrons, now here you see the important point, proton and neutron situated in the nucleus, are collectively called nucleons. This is the question asked. Nucleons, that is, what are neutrons and protons collectively known as? This is nucleons. So this was all about the discovery of electron, proton and neutrons. Now I think students, you have understood it clearly about the structure of an atom.